Hi, everybody. Welcome to the Chico SAT review series. And this will be the video number 4 for this unit. We talk about angles, triangles, and the trig functions. So in this video, we're going to cover the last topic, trigonometry functions here. And so if let's try to go through and refresh your memory. So this is what our video number 1. So basically we talk about the angles relation with triangle and the different figures. And this is our video number 2. We focus on the isosceles triangles and the parallel line, those relations. And then this is our video number 3 topics. We talk about the 2 special right triangles, right? And very important ones, 30, 60, 90 degrees triangles and 45, 45, and the 90 degrees right triangles. So in these videos today, we're going to talk about some very basic trig functions here. So we have 2 practice problems we're going to do. Okay, so now let's go to the whiteboard and let's start. Okay, so before we start to try to do the problem, let's do a brief review about the trig functions we learned. And so here, let's take a look here. So if this is my, okay, if this is my triangles here, okay, so in here, and if we have, this is my right angles here, and I call this is the angle thetas here, right? So the thetas here, so the side face the 90 degrees angle, this is, we call this a hypotenuse, okay? And the side we face the angle we are interested, right? So this is the angle theta we are interested here. All right, so this is the angle theta we are interested. And the side we face the angle we interested, this side we call the opposite side. And also, so the same way for this side is right next to form this angle theta. So this we call this adjacent side here, right? That means right next to form it. Okay, so the 3 trig functions we are familiar with, we said this is the sine theta, and is equal to sine, as we say, is opposite over hypotenuse, right? Then the cosine theta, we say, is the adjacent over hypotenuse. And then the tangent theta, we talk about is the opposite over adjacent, right? So when you are in the high school, there are many different ways the teachers try to help the student to remember. So what is the sine, cosine, and the tangent definition? The way I typically tell my students sines, right? Why is the opposite of adjacent? Because the sine, you take a look at here, is S, right? So S here, right? So this is a kind of the S here. Then the cosine is here, so this is the C's, right? So that's why it's adjacent over hypotenuse. Then the tangent here is just like a T, like go this way. So that's why it's opposite over adjacent here. That's the way, I typically show my student, try to remember. And I think different teachers, they have a different way. As soon as you feel comfortable and you'll be able to remember, that's what it's count. So after you know these 3, then the next 3 is here. You should, it's very easy. So the sine, the reciprocal of the sine, we say the cosecants. So the cosecant will just be flipped it, right? So you put a hypotenuse here, and then this is the opposite, right? Then the cosine, the reciprocal, we call it the secants, right? So you flip it. So hypotenuse is here, then this is adjacent. Then the cotangents here is just the reciprocal of tangents. So it will just be the adjacent over opposite, right? So as long as you know the first three, then you know the other three here. They just like you put it, like you reverse it, you flipped it, okay? So basically this is the trig function. So in the SAT level, we're not going to go any, the more advanced, because trig function is basically is a whole semester's class. But from the SAT point, we're just going to focus on very basic definitions. So the problem is they could give you some side, and then want to find the functions. And other things here, like the one of the things I want to mention here is the sine and the cosine relations here, right? Okay, so like in this ones here, okay, so this is the angle theta, so it's the purple angle. So if I said that this is the green angles here, right? So this is the green angle, okay? So if the theta, so if this angle I call it phi here, right? So what is the relations of the theta and the phi? So I know the theta plus phi is equal to what? Is equal to 90 degrees, right? So the sine theta, so if you take a look, right? So here we said the sine theta, if you look at the purple ones here, so let me color code that, so maybe that would be better. Okay, so this is the sine theta. Okay, so I use the purple one, sine theta. Okay, so the sine theta is equal to opposite over hypotenuse, right? So the opposite of the purple is the opposite over hypotenuse. Okay, so now if I look my green angles here, right? So if I look at the cosine, okay, my green angles here, phi here, right? So the green angle phi, all right? So if you look at the green angle phi, so remember the cosine is adjacent over hypotenuse, right? So the adjacent side versus this phi is what? Is here, right? Verse 5 is this OPP, so this will be OPP over what? HYP. So what do they have here? That's why we derived a very, very important relation. So if these two angles they add up to the 90 degrees, then the sine theta really will be equal to, so if you want to rewrite this phi, this will be equal to the cosine, what? 90 degrees minus theta. So as long as they add up to 90 degrees, and then the sine and the sine is one angle, cosine will be another angle. So let's take a look at here, right? So like if I said here, cosine theta, right? So the cosine theta we just defined here, right? So this is adjacent over hypotenuse. So here, so cosine theta is this angle, right? So it's this side, right, related to this purple angle to the hypotenuse. So this blue side is the opposite side for this phi. So that's why I know cosine theta is equal to the sine what? Is sine phi. All right. So that's why, because sine phi is here, right? So this will be the adjacent over what? Hypotenuse here. Okay, so that's why in here we said if, so in here, so if, right, so this is when the side phi, theta plus phi equal to 90 degrees, then you know the sine theta is going to equal to the cosine phi, or you can say the sine phi equal to the cosine theta, right? So I think from the SAT point, this is probably the only properties, for the trig functions that are going to test you. Of course, there were the basic ones. They just give you the side and they want to find what is the cosine theta value, what is the sine theta value. But so this is the one, if the theta plus phi equal to 90 degrees, then we know the sine theta equal to cosine phi here. So kind of divide this here. All right. So remember this, right? So this is very important, right? So if the theta and the phi add up to 90 degrees, then the sine for the one theta equal to the cosine with another theta. All right. Okay, so now let's take a look at this problem here. Okay, so in here, they say for the given triangle RST, see here, a point W is on the RT, right? So they did not tell you where is this W, see here. So I say, okay, so let's assume this is my W, see here. So it could be any points on the RTs here. Okay, so they want to ask you, what is the angle? So here, so if you connect these two, right? So you will get a, okay, so this is the W's here. So they ask you, what is the cosine RSW? Okay, so let's color coding that. Every time I do this, I like to color coding that. RSW is what? Is this green angles, right? So this is RSW, all right? And then WST, okay? So what is the sign WST here? So the WST is this purple angle, right? So this is the WST, this is my purple angle, and the WRSW is my green angle. And then the problem give you, this is right triangles, right? So that's why I know the RSW plus WST is equal to what? Is equal to 90 degrees here, right? So based on what we discussed from the previous page, we know if the two angles, they add up equal to 90, then the cosine of the one angle going to equal to the sine of the other angle. That means the cosine angle RSW is going to equal to the sine angle WST. Right, correct? Do you remember that? See here, that's what I said. If these two angles, right? So be careful, right? So make sure we know how to use it. If these two angles, right, they add up to the 90 degrees. So the sine get one angle and the cosine get another angle, then these two values will be the same. Or sine get this angle and cosine get the theta, that'll be the same. See here. So that's why, so I know the cosine angle RSW equal to sine LWST. So what is these values here we have here? So what is the answers here? Because they are equal, so what do we have? We have zeros here, right? We don't even need to use a Pythagorean theory to find this because we use like the same two angles, they add up to be the what? To be the right angle, then the cosine one angle be equal to sine another angles here. Okay, so let's take a look at problem number N here. Okay, so we say the angle shown below are acute angle, right? So that means both A and B are acute. So hope that everybody still remember what is acute angle mean. That means what is less than what? Is less than 90 degrees, correct? Okay. Okay, so now they say, okay, so now it says here, the sine A equal to cosine B. We said, well, sine A equal to cosine B. Okay, both are like, like the acute angle. So because we just did from the previous page, the sine of the one angle equal to the cosine of the another angle. So what do we come out with? So I know A plus B has to be equal to what degrees here? 90 degrees, right? So then they tell us A is 4K minus 22. And what is the B's here? B is 6K minus 13. This one is equal to 90 so here, right? Okay, so now let's combine. So this will be 10K minus 22, the 13 is what? Minus 35 here, right? Equal to 90. Now here we plus 35 plus 35 here. Okay, so the 10K is equal to what? 125. Then you divide it by 10, you divide it by 10. So what is my final answer? So K is equal to 12.5. Okay, so this is a K equal to the 12.5 here. So both of these problems, right? So we try to, take a look at the trig function. So remember, right? So we talk about, so that's why I want to make sure you have this formula down. Like I said, this probably is the level the SAT problems are going to be. They're not going to be any harder than this ones here. So that's the only one of the properties. Make sure you remember, right? So that's why a lot of when they talk about here, so you need to know if the two angles they add up to a right angle, and then the sine of one angle is equal to the cosine of another angle. Okay, great. That's it. Let's cover this whole unit. We talk about the different angles, triangle, different special angles, special triangles, and some trig functions associated with relations. So so I hope that you understand all this, and those also play a big portion in the SAT exam. They always have a few problems related to these topics. All right. Okay. So if you like this video, feel free to subscribe it. And if you still get confused with something, feel free to leave me a comments here. And I will check my comments and I will try to answer your questions here. Okay, so nice to talk to you, and looking forward to talk to you in our next videos here. Okay, you have a good day, and bye.